if we want to see the impact of climate on the biosphere, then we can look at very specific things. So, let us look at one example where we will see the impact of the mean temperature, annual mean temperature. So, if you average the temperature all days of a year, what is the average over a long term? How does that affect the leaf morphology, the size of the leaf, the shape of the leaf, and so on. So, here is an example that is showing the mean annual temperature on the horizontal axis going from very cold temperatures at 0 degrees centigrade to tropical temperature of 30 degrees centigrade, and on the vertical axis we have the percentage of smooth edged leaves. Okay. So, you can clearly see that as the temperature increases, there is a increase in the size of the leaf if you compare to a colder temperature leaf, plus the edges are serrated in the cold temperature leaf versus the warm temperature leaf. So, basically the morphology of leaf depends on the daytime temperature, nighttime temperature, frost temperatures, availability of sunlight, etc. So, if you have to go back and remember what the leaves are supposed to do, they are basically supposed to capture sunlight, capture carbon dioxide, and when the stomata opens, they are supposed to open long enough so that not too much of the water that has been supplied by the roots is going to get lost to the atmosphere. So, this optimization obviously depends on the temperature, plus at very high temperatures the leaves themselves have to cool down. So, they do it through basically like a respiration or sweating, that is called transpiration. So, there is evapotranspiration, evaporation and transpiration by the plants. So, that determines the size of the leaf, and as the temperature increases they want to sweat more. So, they increase their area. Okay. So, you can see that the percentage of the leaves with smoother edges and larger size increases as temperatures increase. If you look at a map, if you build a model that considers the impact of daytime, nighttime temperatures, frost damage and sunlight, what can the model say in terms of the distribution of leaves we can expect? So, here is a global map showing the maximum leaf size in centimeters squared going from close to 0 to more than 10,000 centimeters squared. So, you can see that the map is showing there are regions like the rainforests of Amazon, Central Africa, Indonesia, the so called maritime continents and so on, where there is essentially no impact of temperature on the leaf size. That means the humidity, temperature, the difference between daytime and nighttime temperatures are pretty minimal. So, the leaves are not showing any impact, whereas if you go over the desert regions or even over the monsoon regions over India and so on, the leaf size is much smaller. Okay. So, the large leaf size in the rainforests are basically fixed, whereas when you have large seasonal variations in temperature, humidity and so on, like the monsoon region, the leaf sizes can display their impact. So, if you think about climate change, we will be changing humidity, we will be changing temperature. So, we will have to track the leaf sizes. You can do the exercise by simply watching the leaf differences in leaf sizes when you climb a mountain, for example. You expect that as you climb a mountain the temperature is going to drop. Does that show an effect on the leaf size as you go up? You have to look for average leaf size. Or you can look at leaf sizes going from a city center to a rural region, because in the city center the average temperature is higher because of something called the urban heat island. As you go to the rural areas, you expect that the vegetation will make it cooler. Of course, you have to be careful because there are some places in India where the rural areas, because of agriculture, have cleared out all the vegetation. So, after the crops are removed, it can be actually warmer than a city center where there is parks and gardens being maintained. So, just look for temperature gradients and watch the leaf sizes, the leaf architecture, whether they are smooth edged or serrated and so on, and that will make a good exercise. And if you start collecting data now, you can over the years see if temperatures are changing, whether the leaf sizes are responding to that.